Okay, section 4.2 has to do with molecular and ionic equations. Okay, so a molecular equation is where you write the reactants and products as if they were molecular species, even though they may exist as ions. The complete ionic equation, you take anything that's aqueous, and this is a very important part here. Okay, AQ. Okay, and write it as separate ions. Okay. And then you identify what the spectator ions are and subtract those or remove those from the equation. And when you do that from the complete ionic, you get the net ionic reactions. So the net ionic is basically you take the complete, you subtract out the or cancel out the spectator ions, and what you're left with is the net ionic equation. Okay. So here's some examples. Okay, so what I just said the last slide is that anything, this right here is the molecular equation. So molecular equation is given to you. You don't have to worry about that. Okay, and then to get the complete ionic equation, I take anything that's AQ and I write those as ions. So just like when I'm identifying how many species there are, I'm going to take the coefficient or balancing the reaction. So 2 times the 1, I have 2 hydrogens. Okay? And I put down the charge for that. I have 2 times 1 is 2 chlorides. Okay? I'm done with hydrochloric acid. Plus 1 times 1 is a barium. 2 plus. Plus 1 times 2, because this is a polyatomic ion, it stays together as a polyatomic ion. So this is 2 OH minus. Okay, you should recognize that as hydroxide. So if you recognize that from naming, you should also recognize it stays together. Okay, goes to form. Now, you notice I didn't draw a line into this because only the AQs get broken apart. So this stays as being 2 waters. And I don't really need to necessarily write down the L. Okay, plus 1 times 1 is 1. Barium, again, has a 2 plus charge. And then 1 times 2 gives me 2 chlorides. Now, if you're given a balanced reaction like this one, then it should still be balanced down here, okay? Meaning the fact I have 2 chlorides, I have 2 chlorides over here, okay? Now, a spectator ion is something like like most of you are in this class, not all, but some of you are in this class. You're just watching the videos. You're not partaking in the videos, okay? So, meaning the fact you don't participate and you don't take notes and that do the problems. All right, so if it's on both sides of the equation, it's a spectator ion, so I can cancel that out. So the 2 chlorides go away. 2 hydrogens, I don't have those by themselves over here, okay? Barium, however, exists here and exists here, so they have to match exactly, okay, in order to cancel out. And I basically have that left, okay? So my spectator ions for this was chloride and barium. And to get the net ionic, so this is the complete ionic. And to get the net ionic, I basically rewrite this having canceled out, or ignoring anything I canceled out. So I have 2 H pluses plus 2 OH minuses goes to form 2 waters. Now, because all the coefficients here are 2, I'm going to divide the whole thing by 2. So the final answer is H plus OH minus goes to form water. And this is my net ionic reaction here. Okay? Now, I have another one. However, I strongly suggest that you pause the video at this point, try to do this one first on your own, and then watch how I do it. Because watching me is not going to help you, okay? Because I know what I'm doing, all right? So again, I'm going to identify the aqueous, okay? And the complete ionic is anything that I just underlined as aqueous has to be broken apart. So 1 times 1, I have a lead. The lead charge on this one is a 2 plus. plus 1 times 2 gives me 2 NO3s. So if it's in parentheses like that, it's a polyatomic ion. Okay, plus 2 times 1 gives me 2 NAs, which has a plus 1 charge, plus 2 times 1 is 2 bromides. Okay, I didn't underline that one, so it stays together. It stays as PbBr2. Okay, but I did underline this one, so 2 times 1 is 2 NAs, plus, again, recognizing that that's nitrate from polyatomic, from naming, so it stays together, 2 NO3. Alright, so that's the complete ionic. Then I go through here and I cancel out. Okay, I've got lead here, but lead does not exist by itself over here. I got 2 NO3s and 2 NO3s. So those cancel out. I got, that really is an A. May not seem like it. 2 sodiums here and 2 sodiums there, so those cancel out. And 2 BRs, but BR is not by itself over here. So the net ionic is basically everything I didn't cancel out. Okay, so I have Pb 2 plus 2 Br minuses goes to form Pb Br2. Now, this one, not all the coefficients were the same, so I don't have to divide by anything, and I am done with this problem. That is the answer. And I'm done with this video.